So we spent the last 2 or 3 lessons working on angle rotations, reference angles, things like that. And that's a lead in to this lesson on special triangles and unit circle. And special triangles is just an application of angle rotations and things like that and reference angles. It's really, really important that you get a really good handle on special triangles and unit circle because it's going to be used extensively in Math 30-1 when we do something called solving trig equations. So if you have to watch this video twice, it's worth it because it'll make your life easier. Something else you need to know is that when mathematicians ask for something called an exact value, they mean they want an answer that's either a whole number, a fraction, or a radical. And lots of times when they ask for an exact value answer, you're going to be using unit circle to help you get that. And you'll see how we do that in this lesson. So the first thing that you need to realize is that the special angles or special triangles come from the reference angles 0, 30, 45, 60, and 90. So those are the angles we're going to focus on. And we're going to talk about how they actually come up with the values of these particular angles. If we draw a 45-degree reference angle in quadrant 1, you're going to end up with an isosceles triangle. And we're going to make these sides 1 on each side. And part of the reason we make them 1 is it's related to the concept of unit circle. Unit circle meaning a length of 1. So we have to use Pythagorean theorem to help us calculate the radius in this case. So we're going to get 1 squared plus 1 squared equals r squared. Well, 1 squared is 1. 1 squared is 1. So we get r squared to be 2. And if we take the square root of r squared, we get root 2 for our hypotenuse. And now if we come up with the ratios for sine, cosine, and tangent, sine is y over r, so it's 1 over root 2. And we learned in the last unit on radicals that mathematicians do not consider a fraction simplified if it has a radical in the denominator. So we have to multiply the numerator and the denominator by root 2. So we get 1 root 2 in the numerator, and root 2 times root 2 is just 2. So if you just remember that 1 over root 2 is the same as root 2 over 2, it's going to make your life really easy. If we do cosine, cosine is x over r, so it's also 1 over root 2 or root 2 over 2. Tangent is y over x. Well, y over x is 1 over 1, which means tangent has a value of 1. So anytime you have a reference angle of 45 degrees, you're going to be able to get one of these solutions as your answer, as an exact value, depending on whether or not you're looking for sine, cosine, or tangent. The other thing you need to remember is these could be negative, because if we're working in quadrants other than quadrant 1, such as 2, 3, 4, these values do have negative, these ratios have negative values in different quadrants. So the next thing we're going to look at is we're going to look at a 60-degree reference angle. And we're going to draw an equilateral triangle. That means all these sides have a length of 2. Well, if they all have a length of 2, and what this means is when we draw this line down the center, it's going to divide this base in half. So that means each part of this base has a length of 1. So we now have to find the length of this altitude here so that we have our y, our r, and our x to set up our ratios. So we're going to get 1 squared plus y squared equals 2 squared, because we know the x and we know the r, but we don't know the y. Well, 1 squared is 1, 2 squared is 4. If you take 4 minus 1, you're going to get y squared to be 3, so when you take the square root, you're going to get y to be the square root of 3. So now when we go and form our ratios, sine is y over r, so sine is going to be root 3 over 2. Cosine's x over r, so it's 1 over 2. And tangent's y over x, so it's just root 3 over 1 or root 3. So there's our 3 ratios for a 60-degree reference angle. The last one we're going to do is we're going to look at a reference angle of 30 degrees, And we're actually going to take this equilateral triangle and we're going to turn it on its side, because if you look in a 30 degree, if you have a 60-degree reference angle here and a 90-degree angle here, that makes this angle up here 30 degrees. So we're taking this particular triangle and turning it on its side. So it's still an equilateral triangle with each of the sides being 2 and these sides here being 1. That looks like a plus sign. I'm going to fix that. So now we've got to figure out this x quantity using Pythagorean theorem. Or we can remember that that quantity is the same as this altitude here. So this is actually √3 from our previous triangle. So if we now look at sine, sine is y over r, so sine is a half. Cosine is x over r, so it's √3 over 2. And tangent is y over x, which is 1 over √3. And again, remember, we can't leave it like that. We can't leave radicals in the denominator. So we multiply by √3 by the numerator and the denominator. So 1 times √3 is √3, and √3 times √3 is just 3. So the tangent of 30 is √3 over 3. So we've got all of these ratios. We've got 3 ratios for 45 degrees, 3 ratios for 60 degrees, and 3 ratios for 30 degrees. If we look at those in relation to our special triangles, here are the special triangles we came up with, the 30, the 45, and the 60, exactly the way we just drew them in our investigation. Now, if we look at this as being a unit circle, a unit circle means we need to make these hypotenuses 1. It means the radius of the circle is 1 unit. So in this first triangle, the 30-degree reference angle, if we divide everything by 2, that means we get a 2 divided by 2 is 1, 1 divided by 2 is a half, and √3 divided by 2 is √3 over 2. If we do the same thing in the second triangle, if we divide everything by √2, √2 divided by √2 is just 1. 1 over √2, remember, is √2 over 2 in each of these cases. Again, here we're going to divide everything by 2, so 2 divided by 2 is going to give us 1. 1 divided by 2 is going to give us a half, and √3 divided by 2 is going to give us √3 over 2. So these are the actual triangles when they're in a unit circle, a circle of a radius 1. So if we summarize everything we've got here, if we look at the sine of 30 degrees, well, the sine of 30 degrees is y over r, so it's a half. The sine of 45 degrees is √2 over 2, because our y value here is √2 over 2, and if you divide that by our radius, which is 1, it still gives us √2 over 2. And the sine of 60 is √3 over 2. If we go back to cosine, cosine is all of our x quantities. So the cosine of 30 is √3 over 2. The cosine of 45 is √2 over 2. And the cosine of 60 is a half. If we look at tangent and we complete this table, it might be a little bit hard to look at tangent as y over r in terms of that. So if you go back to your triangles, if you go back here, if we want the tangent of 30 degrees, the tangent of 30 degrees is √3 over 3. The tangent of 45 degrees, well, we calculated that. The tan of 45 is 1. And the tangent of 60 is just √3. So this particular chart becomes quite important because these reference angles of 30, 45, and 60 are going to be the reference angles we work with. So you could just use this chart to help you get values of sine, cosine, and tangent, and you'll see how to do that momentarily. The next thing we're going to look at are the other 2 reference angles, the 0 degrees and the 90 degrees, and we're going to look at the exact values of those particular things. Now, before we do that, I'm just going to draw a coordinate plane and remind you that 0 degrees is here and 90 degrees is here. Now, if we put a circle in here, and this is the radius of our circle, that means this point over here has an x value of 1 and a y value of 0 because we're not moving up or down. Here, 90 degrees, if this radius is 1, that means y has a value of 1 and x has a value of 0 if we pick this point here. Because you're going up 1 on the y-axis, but you're not moving left or right on the x-axis. So this x and y value in each case are 1 and 0. So if we look at the sine of 0 degrees, well, in this case, because we have the point 1 and 0, we know that x has a value of 1, y has a value of 0, and our radius is 1, so r has a value of 1. So sine is y over r. Well, y is 0, r is 1, and 0 divided by 1 is just 0. Cosine is x over r. Well, x is 1, the radius is 1, so cosine has a value of 1. Tangent is y over x. Well, y is 0, x is 1, so 0 over 1 means tangent has a value of 0. If we now go to 90 degrees, x has a value of 0, y has a value of 1, and our radius is 1. So y over r is going to be 1 over 1, which gives us a value of 1. Cosine is x over r, which is 0 over 1, or 0. Tangent's y over x. Now you have to be careful here. Y is 1 and x is 0. If we try to go 1 divided by 0, that's undefined. We cannot divide by 0. So we do not have a exact value for tangent of 90 degrees. These are called quadrantal angles, 0 and 90, because they are right on the edges of our quadrants. So they're going to be special angles you're going to need to refer to in our upcoming work. So we can extend our diagram or our chart here and include 0 and 90. It would be using the exact same chart as we had here. We would be recopying this chart, and then we would be using the values from this particular chart. So if we go back and do that, the sine of 0 is 0, and if we're copying out from our other chart, these are the values we get. Cosine of 0 is 1, and then cosine is root 3 over 2, root 2 over 2, a half, and 0. So I'm just copying these values from the charts on our previous page. That's all I'm doing. I'm consolidating that information. If we do tangent, tan of 0 is 0, tan of 30 is root 3 over 3, tan of 45 is 1, 60 is root 3, and it is undefined at 90 degrees. So here's all that information we've talked about consolidated into one chart. You might want to memorize this chart, or we're going to look at some ways, some memory tricks to memorize this soon. So what they want us to do is they want us to now use this chart to determine some exact values. So the first thing they want us to look at is the sine of 210. So if I look at 210 degrees, 210 degrees is down here in quadrant number 3. And if I figure out its reference angle, 180 plus 30 gives me 210. So my reference angle is 30. So I'm actually looking at the sine of 30 from my table, but we also need to look at our cast rule. In quadrant 3, the only thing that's positive is tangent. So that means sine is going to be negative. So when I go up here and I look at the sine of 30 degrees is a half, but we have to make that answer negative. So the sine of 210 is actually negative 1/2. If we look at 300 degrees in the next question, 300 degrees is in quadrant 4. And remember, we always draw a right triangle back to our x-axis. 360 is here. how much does this reference angle have to be to get from our terminal arm to 360? It needs to be 60 degrees because this is 300 degrees here, and if I go 60 degrees more, it gets me to 360. So they want us to find the cosine of 60 degrees because our reference angle is 60 degrees. If we look at our cast rule, in quadrant number 4, cosine is positive, so our answer is going to be positive. And if we go to our chart and we find the cosine of 60 degrees, the cosine of 60 degrees is actually positive 1/2. Now let's look at 225. 225 is down here in quadrant 3. Cast rule tells us tangent is positive, and our reference angle here, 180 plus what's going to give me 225? Well, 180 plus 45 degrees. So I'm going to find the tangent of 45 degrees, and it's going to be positive. So I go to my chart, I go to tangent, I go over to 45 degrees, and I find the answer to be 1. So this is the way of getting an exact value for any particular angle in a quadrant that has a reference angle of 30, 45, or 60. So we're going to use that to help us solve a couple of problems. The next one says, without using technology, determine the exact values of cosine theta equals negative root 3 over 2. Okay, so the first thing we need to look at is we need to look at where, in what quadrants are cosine negative. Well, cosine's positive in quadrant 4 and quadrant 1. So cosine's negative in quadrant 2 and quadrant 3. So the next thing I need to do is I need to go back to my table and I need to look and see, well, cosine has a value of root 3 over 2 if we have a reference angle of 30 degrees. So this is telling me that the reference angles in quadrant 2 and in quadrant 3 are 30 degrees. So now I need to figure out what's the measure of this angle in quadrant 2 and what's the measure of this angle in quadrant 3. Well, in quadrant 2, it's 180 minus 30, because 180 degrees is all the way around, halfway around in quadrant 2, but we're going 30 degrees less than that. So one of our answers is 150. In quadrant 3, we're going 180 degrees plus 30 degrees more, which gives us 210 degrees. So what we're actually doing is we're doing the reverse of what we were doing a second ago. We're actually using these answers to help us figure out angles that are in different quadrants. Next one says tan theta is undefined. Okay, well, if we look at this and we look at where tan theta is undefined at 90 degrees. That's what our table says. So 90 degrees is up here, but the other place I have a reference angle of 90 degrees is at 270 down here. So straight up, I have a reference angle of 90. Straight down, I have a reference angle of 90. So in this case, because they lie exactly on these quadrant lines, those are our two answers for this particular question. All right, last example for this portion of this video. It says we have a point on a terminal arm which is -3 and root 3. It says without using technology, do the following. Draw the angle in standard position and mark point P. Okay, so if we have -3, well, that means I'm -3 on the x-axis, and root 3 means I'm root 3 on the y-axis. So that means our terminal arm is over here in quadrant 2. It says, state the values of x, y, and tan theta. Well, x in this case is -3, y is root 3, and tangent is y over x, which is going to be root 3 over -3, or -3 root 3, or negative root 3 over 3. It says state the reference angle for this angle of rotation. Well, if I go back to my table, the one that we created, and I look at my table, and I look at tangent, tangent is root 3 over 3, when we have a reference angle of 30 degrees. So in this particular question, our reference angle is 30 degrees. So there we go. A little bit about special triangles, how we can use them to find ratios, and how we can use them to find angles.